Hey, in this video, we're going over question 13 and a few more from your ICB-1 review quiz. Look at the title of the video, and if you're looking for feedback on a question that's not included in the title, then find a different video. So this is a really important reaction to biochemistry. We have this idea of a polymer. So think about the word poly. You know it from polygon. You might know it from the word polygamous, which means having like multiple lovers. Poly means multiple, right? And so what we're looking at in this question is two separate pieces. They're not bonded at this point, that are about to go through a chemical reaction represented by the arrow. And after they do, they come together to form a polymer. So it's called a polymer at this point, because we have two pieces that are now together, linked as one. So this is the polymer that we're talking about. And what we started with over here were two monomers. Mono means one. So we have this single piece, or the single glucose molecule, and then we have another one over here. So we have two monomers, and through a chemical reaction, they form to make one larger molecule that's containing what used to be multiple pieces. So that's why this one here is called the polymer. So you have to know that first. Okay. The next thing you have to notice is that the hydroxyl or alcohol group from this one and the one from this one, if they get placed near each other, they're going to be attracted to each other. That has to do with polarity, which we'll talk about with other review questions. But they'll be attracted to each other enough that if they have enough energy and they bump into each other with the right spatial orientation, they'll go through a reaction. And notice that when they do, check this out. The hydroxyl group that was here is no longer right here. And the one that's here is no longer right here. But this oxygen atom that's right there, where did that come from? Well, if you think about it, here we have, between these two circled areas, we have a total of 4 atoms. 2 of them are oxygens and 2 of them are hydrogens. Out of those 4, we only have 1 atom left, and that's this oxygen. So that means we lost 3 atoms. Like, how do you lose 3 atoms? Well, you can't. According to the law of conservation of matter, they must be somewhere. Where are they? Ah, they're right here. Water is a 3-atomed molecule, right? So the formation of this polymer basically disrupted these relationships. One of these 2 oxygen atoms became the one that bridged these 2 monomers into a polymer. The other 3 atoms get kicked out and they form a water molecule. So water is formed here. Now, you need that to think about the answer. So hopefully, if you got this one wrong, hopefully you were at least thinking it's one of these 2. Now, I bet that your previous teacher, when he said hydrolysis, I bet he said hydrosplices, which is not a correct term. It's just a way of helping you remember stuff. To splice is to cut something. We're not cutting 2 molecules here. We're connecting 2 molecules together. So it's not hydrolysis or hydrolysis. It's dehydration synthesis. Now let's think about why this name makes sense. First of all, why is it synthesis? Well, because when you synthesize something, you put 2 things together. Here are 2 things. They've been put together. So synthesis occurred. It's called dehydration because, check it out, the molecules that we originally had, they lose water. This water is no longer inside the chunks of matter that we used to have, right? So that means these things have lost water. How do you become dehydrated? You become dehydrated after you lose water. So this is a very sensible name, and it's one you'll hear a lot about this semester. Okay, let's look at this one. So suppose you have an enzyme that builds a polymer like the one above, except the polymer is 1,000 monomers long. How many water molecules would form in the process? Well, in this case, we have and I'm going to draw this simply. Here we have two monomers represented by these dots. They're bonded together. Oh my goodness. Okay. They're bonded together, and we have one water that was lost, right? Now I want you to imagine that we add another monomer to this one. Won't that lose another water molecule? So that would be two molecules lost to form a polymer that's 3 long. What if we add another monomer to this polymer? We're going to lose a water molecule in that case. So now we have a polymer that's 4 units long but has lost 3 waters. We add another one. Bond, dehydration, synthesis forms another water. Now we have 5 molecules strung together, 5 monomers strung together that produced 4. So the pattern here is the number of monomers strung together minus 1 equals the number of waters. So N, or number of monomers minus 1, is what you need to figure this one out. So this one says you have 1,000 monomers. So that means that 999 water molecules will form in the process. Okay, 15. What type of chemical reaction does the exact opposite of what the diagram shows? Okay, so this diagram is exactly the same as number 13. Number 13, we said the answer was dehydration synthesis. We explained that a lot. Now, this question is saying, well, what about the opposite? So instead of the reaction going that way, let's say we took a polymer and we broke it into 2 pieces, 2 monomers. That's what this arrow in the other direction represents. That would be the opposite reaction. That's hydrolysis, or fluently pronounced hydrolysis. And I think we'll call it quits for this video. So this video was about questions 13 through 15.